Hi everybody and welcome to this video. In this video, we're going to look at the Gauteng Department of Education Preliminary 2020 Paper 1. We're having a look at question 7, which is on the financial maths. Please make sure you try this question before watching this video, and please make sure that you have went through our series on financial maths before attempting this question. If you're finding you're struggling with any of the questions, then please go back to that and review sections, the corresponding sections. So let us start. So here we have questions. So Sarah's investment earns an interest of 11% per annum compounded semi-annually, and Mary's investment earns an effective interest rate of 11.42% per annum. Whose investment, Sarah's or Mary's, earns a higher interest rate per annum? So what happens in this case is that we can't compare the interest rates as is, because one interest rate, which is Sarah's, is a nominal interest rate, and we have that Mary's is a effective interest rate. So in order for us to be able to compare interest rates, we should have the effective interest rate for all. So we should convert Sarah's interest rate into a effective interest rate. So we're going to use our nominal to effective formula, which is 1 plus I, in this case 2, because it's semi-annually, over 2 to the power of 2 is equal to 1 plus I effective. So that is the formula. So then we're going to substitute our values. We have 1 plus 0.11 over 2 to the power of 2 is equal to 1 plus I effective. And then we're going to subtract 1 on each side. So we have that I effective is equal to 1 plus 0.11 over 2 squared minus 1 to get I effective by itself. Typing that into our calculator, what we get is the effective interest rate is 0.113, and that we can write as 11.3%. Okay, so that was the calculation, and then we have to say what is the conclusion. So who earns a higher interest rate? Well, Sarah's is 11.3 and Mary is 11.42. So this year is less than the 11.42%. So therefore, Mary earns a higher rate. And there we have our completed question. So let's have a look at the next one. It says Buhle decides to start saving before retirement. She makes payments of 10,000 Rand monthly into an account yielding 7.72% per annum, compounded monthly starting on the 1st of November 2016, with a final payment on the 1st of April 2026. Calculate how much will be in the savings account immediately after the last deposit is made. So let us first write out the stuff that we were given. We have that the monthly payments, also X is 10,000 Rand. We have a interest rate, which is a nominal interest rate, so it's I12. So it's 0.0772. I've already converted it into a decimal fraction. And we want to know how many payments, what is the number of years, or let's say the number of months between that. So we want to know how many months are between the 1st of November 2016 and the 1st of April 2026. So between that, there would be 9 full years. And then what we're going to get is then from 1st of April 2026, 1st of April 2025 so let's just say the 1st of November 2016 to the 1st of November 2025, that is 9 years. And then we have to count the number of months from the 1st of November to the 1st of April, because it's not full years. So if we count that, let's just get out the calculator. So 9 full months, so I mean 9 full years, so it's 108. So it's 108 for these, plus from November to April. So and then counting how many months from November to April, it's December, January, February, March, April. So it's another 6 months. So then it's 114 months. So the first thing is to calculate how many payments. Okay. So then that's how many monthly payments have been made. The next thing is we want to calculate the future value. So we have to identify which formula we're using. So then plugging in our formula, so the future value is x times 1 plus I12 over 12 to the power of m times n, so in this case it's 114, minus 1 all over your interest rate, so I12 over 12. Okay, then we substitute. This is 10,000 times 1 plus 0.0772 over 12 to the power of 114 minus 1 over 0.0772 over 12. And then once again, we type that into our calculator. So typing that into our calculator, we get that the total amount is 1,674,501.44 cents. Okay, so for this question, the approach to write down what you're given first and then use the formula and substitute is really handy. So then we have, at the end of the investment period, Buhle reinvests the full amount in order for her to be able to draw a monthly pension from the fund. She reinvests the money at an interest rate of 10% per annum compounded monthly. If she draws 30,000 Rand per month, for how long will she be able to receive full payments of 30,000? Okay, so we're going to now write down what we were given again. So 7.2.2. So now she's making monthly withdrawals of 30,000. So our X is 30,000. Our present value, how much it's worth at this time, we know is 1.674 million. So the amount that we just calculated. Her interest rate is a monthly interest rate of 10%. And we want to know what is it that we're solving for. We want to know how many full payments will she receive. So let's say NM, we want to solve with the monthly payments. Okay, so then let's put in the formula. Our present value is equal to X times 1 minus 1 plus I12 over 12 to the power of minus NM all over I12 over 12. So the present value is 1,674,501.44. It's equal to 30,000, that's her monthly payment, times 1 minus 1 plus 0.1 over 12 to the power of minus NM, all over 0.1 over 12. So then we go ahead and solve. So dividing both sides by 30 and multiplying by 0.1 over 12, we get 0.46513 is equal to, with a few other decimal places, is equal to what's in this bracket, which is 1 plus 0.1 over 12 the power of minus nm. And then what we're going to do is we're going to subtract the 1 on both sides and divide by the negative. So then what we're going to get is 0.53486. Okay, let's do it step by step. So first subtract on both sides. Okay, then we divide both sides by a negative. Sorry, 1, 0. Okay, so power of minus nm. Then we want to solve for the exponent, so we use logs. So our exponent minus nm becomes the subject. Log, the base of the log is the base of our exponent, so 0.1 over 12. And what's on the other side will go next to our log. And then what we get is minus nm is equal to 75.4. So then when we divide both sides, we get minus nm, positive nm is equal to 75.4. So therefore, she will get 75 full payments. Okay. Let us have a look at the final question. So it says, after withdrawing 30,000 for 20 months, Buckley requires 1,500. Determine whether she can access this amount from her annuity. So we want to know what is the value after 20 months. Okay, so there's two ways that we could do this calculation. Okay. So one thing we could do is that 1 point, so she had 1.67, how much did she have? 674,501,44. Then she's been making withdrawals of 30,000, right? And then after 20 payments, we want to know how much she has. So we could do two things. We could calculate what is the value of the, so we can take this amount to the future, so add the interest it would accumulate, and then subtract how much the future value of those payments. That's one way we could calculate it. The second way we could calculate it is by calculating the present value of all of these payments that still not have been made. So the easiest way is to calculate the amount of money that the future payments would have had. So in other words, we're going to calculate the present value of the future value, the payment. So the present value, so let's write out our information. Our monthly payments are 30,000. The interest rate is still 0.1, so 12%. And this time, how many payments are left? Well, if she made 20 payments, then there's going to be that's 75.4 payments left. So remember, there was 75.4 payments in total. So she's going to have 55.4 payments left. Okay, so she had a total of 70, from our previous question, she would have gotten a total of 75.4 payments. If she's made 20, she's going to have 55.4 left. We're going to work with the full payment, so we're going to leave out the 0.4. So to this, we're going to calculate the present value of those 55 payments. So here we have that it's x times 1 minus 1 plus 0. Okay, let's put in the actual values. So it's 30,000, 1 minus 1 plus 0.1 over 12, so power of minus 55, all over 0.1 over 12. So if we then type that into our calculator, the present value is 1,319,260,60. So you can see that this is less than 1.5 million. So will she have enough money? No, she will not have. Okay, so please, if you haven't understood this video, please review our video on the balance of loans to understand how do we calculate a loan value at a particular time. And if you've had any problems with any of these financial maths video questions, then please re-watch the financial math series. Thank you for watching. Don't forget to subscribe and like. Thank you. Bye.